So here we have step one of building this battery bank with the used battery modules from a 40 kilowatt hour Nissan Leaf. I've already been through and tested each module individually for its capacity. These are the numbers you see beside the terminals. I've got 20 here that I'm going to wire up together. I've used the underneath plate from the battery pack cut down to size so that it will take 2 stacks, and again a top plate so I can put them under good compression just with some M6 threaded bar. At the moment I'm not cutting the bars off because potentially this system's going to get extended later on, and all I've got to do is undo the retaining bolts and drop more modules on if necessary. But anyway, that's the first 20 laid out. I've got to sort out the exact layout that's needed, but I think we're looking on this one at 14S 5P if I remember right. So then got to wire up the modules in the sets of parallel first, and then I can series those banks together, and then I'll put the inverter, sorry not the inverter, the BMS, just using a off-the-shelf JK BMS, one of the new ones with the communications built in. So I'll keep you up to date as I progress. So today, continuing the build of this solar storage system with the used Nissan Leaf ZE1 modules. Today the cables arrived, so I've got all the parallels set up. So they're all batched in parallel series of 5, ready for me to do the series connections tomorrow, and then we'll end up with the right voltage that we're looking for, and I can plumb in the BMS. I've made up an aluminium mounting plate for the BMS and the control unit that comes with it, so this one will talk directly to the inverter, etc. So we've got the stop and start button here too, but it's an aluminium plate. It's at an angle to the battery pack so that when the pack is mounted on the floor, then it'll still be pointing slightly towards the user, and that helps to allow the hot air to escape up the back. Anyway, makes a nice heat sink for the BMS as well. So I've got the temperature probes, there's 4 of them ready to go down the back of the pack. I've got the battery positive ready to line up here on the 56 volt maximum, and then I've got these 16 which need to go to the relevant cells, and then it's ready to switch on. Making progress. So the wiring on this battery pack is finished. We've got 56 volts ready to go, which is going to allow us to go up to 3.75 volts on each cell. That's very safe on these because these will take up to 4.2 very comfortably, but it means that even if it's left sitting fully charged at the full 60 volts, it's not going to cause any problems with stressing the cells. So we've got 16S4P, so 16 cells in series with 4 lots in parallel. You can see how the parallels are all done first, and then the series are then joined up from the parallels afterwards. So it's on to the BMS now. So next step completed. I've got all the BMS wiring sorted, so there's 16 connectors this side, 16 connectors this side. They all feed back up to the BMS here. The temperature senders which feed down the back here, these still have to be put in position, but I've got the BMS mounted solidly, and I've got the communications board mounted so that it's possible to get to the connections behind. So got to put the battery minus up to the BMS here, and then we're ready to look at going live and giving it a test. Now from the back of the battery pack, it's a little bit difficult to see, but I've got the 4 thermistors nicely spaced in the battery in some cable trunking which is cable tied on. So this battery pack is now complete. The BMS is wired in and fully functioning. It's talking to the application that's downloadable from the QR code. I've got my battery charger running on it just to confirm that everything's working on the charging side and that the BMS will shut off when we get to the voltage. I'm only taking them up to 3.5 volts at the moment, which is perfectly safe, but it just gives the system a chance to run through. So yeah, all good. Going to ring the customer, let him know it's ready to collect.